going to do some basic trig identities. And the reason why I'm doing this is because I kind of wanted to have a little refresher for myself. And I was talking to a buddy of mine, we were talking about trigonometry and all the cool things that trig has to offer. And I just kind of want to freshen up. So, lucky you, I'm going to do this with you. And here's what you need to know. We're going to be talking about something called the unit circle. And the unit circle is really something that's brought nothing but frustration and anger to me for pretty much all of my life. I've never really liked the unit circle, but here's what you do need to know. The unit circle has a radius of 1, all right? If you understand that, you're pretty much good to go. And you won't get as angry as I do. Anyway, we're going to have some angle called theta, which, if you don't know that, you should probably just stop this video now and I don't even know. Go and do something else. All right, so I have my x-axis, my y-axis. Let's take a look at these angles here. So sine of theta. Sine is opposite over hypotenuse, which is going to be y over r. All right. The cosine of theta is the adjacent over the hypotenuse, which is x over r. And the tangent of theta is really the opposite over the adjacent, which is y over x. So you do need to know those. And if it helps, I'm going to show you a little mnemonic, no, it's not a mnemonic device. A little trick that my old teacher, Sister Catherine, used to show me. She said, "You run X-rays, you examine." All right, so you run X-rays, you examine, and I'm sure she knows that examine was spelt with an E. Anyway, the only thing that you're not going to actually be able to figure out pretty much on your own is the fact that these are the inverse functions. So this is really 1 over sine of theta, which would really mean it would just be r over y. And secant is 1 over cosine of theta, which would just be r over x. And the cotangent is obviously 1 over the tangent of theta, which would just be x over y. So those are the only things that you really can't just figure out on your own. But these down here, this is where it gets good. The sine of theta over cosine of theta is equal to, if we take a look at this, is really equal to y over r over x over r. Well, the cool thing is, if you multiply this by r over r, you're going to get y over x, which happens to be the tangent function, the tangent of theta. Cosine of theta, well, you should guess cosine of theta over sine of theta. You should probably be able to extrapolate what's going to happen here. I'm going to have x over r over y over r, and we're going to play the same trick by multiplying by r over r, which is legal because r over r is 1. And we're left with x over y, which means we're left with the cotangent of theta. You'll see that up there. Now, what's sine squared plus cosine squared? I don't know. Let's see. Sine squared would just be y squared. Oh my goodness me. That went tragically wrong. It'd just be sine squared of theta plus cosine squared of theta would just be, well, sine is y over r, so y squared over r squared, plus cosine squared, which is x squared over r squared, gives me y squared plus x squared over r squared. But remember, y squared plus x squared, if you go back to your picture, you'll realize that this is a right angle triangle, which means y squared plus x squared equals r squared over r squared, which is 1. So that's the Pythagorean identity. Sine squared plus cosine squared of theta equals 1. Now, what about 1 plus the tangent squared of theta? Well, this is a little bit tricky. So let's see. I'm going to have 1 plus the tangent squared of theta. And I know that tangent is y over x. So y over x. But remember, it's squared. So what I'm going to do is I'm going to change this 1 into x squared over x squared plus y squared over x squared, which gives me a common denominator, and so I get x squared plus y squared over x squared. But remember, x squared plus y squared really equals r squared. So I'm really left with r squared over x squared. Well, up here you'll see that r over x is up here. It's secant. So I'm going to change this into r over x times r over x, which is really secant of theta times the secant of theta, or as you guessed it, the secant squared of theta. So 1 plus the tangent squared of theta is really equal to secant squared of theta. Now, you might be saying, oh my goodness, this is out of control, messy, and you would be correct. So let's take a look. We're going to do one last one. 1 plus the cotangent of squared of theta. And like I said, the nice thing about this is, if you don't have these memorized, don't worry, because you don't need to. You don't need to have these memorized. Well, cotangent squared is really, well, cotangent is x over y, so that's going to be x over y squared, which gives me 1 plus x squared over y squared. I'm going to turn that 1 into y squared over y squared plus x squared over y squared. Now I have my common denominator, which means I have y squared plus x squared, which I'm hoping you're going to remember from above is really the same as r squared over y squared, which is really r over y times r over y. And let's see what happens when we have an r over y. Oh my goodness, we have a cosecant of theta. Well, since I have two of them, I'm going to have cosecant of theta times cosecant of theta, which is just a nice long way of saying cosecant squared of theta. So 1 plus the cotangent of theta is equal to the cosecant squared of theta. And that are my basic trig identities. I'm not going to get into the negative values right now, like sine of negative theta, cosine of negative theta, tangent of negative theta. But that's for another day. All right, I hope you enjoyed. Thanks. Bye.